Well, hello, everyone. I guess I was self-moderated here, so it's sort of cool. Thanks for coming. I know it's late in the sequence of presentations, and I know I'm one out from lunch for you guys, so I really appreciate you guys coming. Like I said, my name's Pete Lega. I've been coming to USENIX since I started my career about 30 years ago. My first USENIX was in 1989, back in the day. If you told me then that I'd be going to a culture track at USENIX, I would have scratched my head. And then if you told me I'd be presenting on something like culture, I really would have scratched my head. So, anyone here recall FaceSaver? Oh, okay. Well, it was like the Tom Cruise era, sort of, and, well, explanation. FaceSaver was a project at Bell Labs where they thought it'd be really cool to put pictures and save a database of employees so that you could put it up against your email every time you got your email in from your UUCP feed, if that means anything to anyone. So I actually managed to find that, and it was actually very hard to find that. I've been working in health science for about a dozen years, and it was my first ascent into health science. Prior to that, I worked in finance. I worked at DEC as a kernel hacker for quite a while, which is where I was first exposed to USENIX. And then I did a lot of work with the European Commission around digital content. So right now I work at this really cool intersection, which this relates to around health science, data, and actually the cultural shifts as you bring these leading technologies into a long-established regulatory environment, such as pharmaceuticals in my case. I've been on a journey for the last 3 years, taking DevOps from a greenfield all the way up to what they call a qualified platform in a health science environment. I've also been cultivating a community that consists of legacy established professionals in the field for decades, and actually very new talent coming in from all sorts of industries and all sorts of startups and even larger companies, and who've never had an experience coming into this regulatory kind of environment. I'm assuming some of you are in the space. How many here are somehow touching regulatory in some way? Oh, excellent. You're my people then. How many in like a health science related or okay. So for some of this may be, you know this already. For some it may be an interesting view, because some of these things, even coming in with 20, 30 years of experience, were lessons to me, and trying to transform this kind of environment. We came across several things that in one way may be obvious, in other ways they were surprisingly important. So what I want to talk today to you about is the lay of the land for a DevOps person moving into the space, the vernacular, sort of like the tourist language of when you're in it, and these patterns that we've seen of onboarding dozens of people or bringing them into the space, and the aha moments, and sort of the strategy we've had around creating community and actually getting work done in this kind of environment. And then finally, my personal message is more about the huge opportunity that exists in this space when you start taking leading technologies that are actually on a high acceleration curve like DevOps and mapping it against what's going on in the sciences. So let's get started. Number one, this is my own presentation. I'm not representing any company, and some of the data here, let's just say it's metaphorical. Just trying to keep myself able to come to conferences. Okay, so for me, this is my context. In health science, there's literally thousands of potential therapies that are in some form of creation or invention. Less than, rough number, 10% or less actually make it into somebody's hand. And that's regarded as successful, and it's the nature of science. So there's this constant churn of failing fast on a daily, weekly basis, and then when there's something that shows progress or there's a new discovery, they quickly want to pivot and put resources there. And that also maps to all the people that support them, like the technology. But at the same time, given what they're doing, it has to be done with accuracy, an incredible amount of discipline, and all the supporting processes around it. Because if you fumble in research, or you get the data, the systems that generated data wrong, or oops, you installed a server that for some weird reason was operationally unreliable, that could have a downstream effect years later of how accurate is what you built. Would you trust the therapy? Would you trust the airplane? Would you trust the nuclear reactor in a regulatory environment of the result of that mistake? So the notion of a parrot in DevOps, you have to take with a different kind of view. You have to really be cognizant that you have to move fast. You want to move fast, but you have to do it incredibly, absolutely safely. And this is the cycle. This is realistically how long it takes in general for things to happen. So this is sort of the problem space. So as you sit here at the conference, a good portion of you represent the perfect storm here. When we talk about the technology, data, I believe we're at an inflection point where we have the things to do amazing things, and we don't fully utilize them yet. We're still exploring what do you do with this capability. Take out your iPhone. You've got the capacity of some small universities 15 years ago in your pocket. Is it truly being used to its full potential? And then you have talent and culture. You have people like you and other emerging talent from the academic spaces all coming in with the ability to solve these problems at scale, and the skill sets and the cultural sort of shifts of how we work to support it. And now health science is actually at the same place. They're using data to move very quickly to work on that cycle time. And you're seeing it now with all the novel therapies and things going on in that space. You probably sense an acceleration going on, but the technology is lagging, right? Because it has to move very safely, very fast, very safely and very accurately. And it's sort of competing or at tension with DevOps and other ways to work fast that are iterate, fail fast, iterate, improve. So there's this maybe obvious tension, but there's other synergies there. So where we are right now, where I am, is we started out with a greenfield a few years ago, and we slowly iterated from basic capabilities in terms of DevOps all the way up to, and we're right now roughly between the partially and fully qualified environment. Significant portions of our DevOps environment are able to be used for this type of work. And it was an iterative process where we had to actually, in effect, make people understand how it works and the models of how it works. It's not big bang, it's small iteration, it's Scrum, it's Agile, right? So you might think when we hit the end point here that we're finished, but actually we're not, because what we've done is we've established the tool, so to speak, and the platform to do the work. And here's where it gets interesting. The inspiration for this presentation is sort of trying to capture what I've observed happening when freshly minted technologists or programmers enter the space. And they think, or they seem to think, it's mostly about coding, go do the shiny thing over time, and iterate to new things. In this space, what they start learning, it goes like this. They come in, and then their tasks are divided among coding, some testing, and they sort of throw it over a fence, and it gets operationalized. Over time, as they mature, they evolve into a DevOps SME, and they start focusing more on CI, CD, and building the tools that support what they created. This should all be familiar, I would think. And then when they get in their groove, a fully competent, fully functioning DevOps engineer, they recognize that they have to provide the support functions around what they build, the documentation, the artifacts and the code and the automation that lets it live and move forward. And that's sort of where most stories end in a lot of industries. They just do this and rinse and repeat. And they're really good juggler tools, right? I was going to get a guy with chainsaws, but that would imply, something bad happens. But wait a minute. So we're in software. This is the typical model. It's DevOps, and the business. And they've come from a spot, or historically it's come from an environment where it was, a dev organization, an ops organization, waterfall versus agile. And you've sort of got through the dissonance around that, and it affected things like, the processes, procurement, even how you develop talent, but you've sort of gotten past that. Now what? You go into regulatory, and suddenly there's this whole other component called quality. And it's not just, quality is job one at Ford, or, that sort of thing. It's a capital Q, and it's a loaded term, and it represents that whole segment of what happens in these environments that keeps it safe and predictable and allows it to keep things and build big things at scale for people or for things, to the point where these things are so important or big that they're regulated, right? So the government, you came here on a plane or a train, there were regulations and things that happened to ensure that that plane was built safely, and that they could reproduce how it was built. And if something goes wrong, they know how to react to it, and they have the evidence to help them debug what went wrong. So now, that's big. And you add that responsibility onto the technology people, and all of a sudden, oh my God, look, there's even more work. And it's important work, but there's more diverse work requiring competency and effort. And to some, it could really be a big weight to them. I know when I came in, and I know when we bring in freshly minted technologists, their first reaction, and it ends well, but their first reaction is, boom, oh my God, I have to do my work, I have to move quick, I was used to moving quick, boom, now I have to do this to move forward. So there's the opportunity, though, that you've got a highly trained, competent, first follower type of technologist in an environment with people who understand this notion of quality, which is a whole discipline that's probably close to a century old. And you want to be able to transform that into something else. So once we can get past that and educate and sort of do social engineering, change the organization to where quality is an integral part of what we do, that DevOps person has a new competency in health science or regulatory, and they can actually become an orchestrator. They understand all the moving pieces, they understand all the processes, they're dealing with highly competent people and organizations, and they can actually still do more coding and other things like it technologically, but you have to sort of figure out how they can do it and how they understand what they need to work on. So, what is this quality organization? Or quality, really, at a glance. There's some very high-level objectives, and they're taken quite seriously. What you see here, they really have to take what starts even way out at the portfolio level of what's being decided to be worked on, all the way through in a controlled way with all the evidence around it, that what you're building is accurate, it's reproducible, through something called validation and qualification, which I'll get into in a minute. There's enough governance around it that you know how to approach it, you know how to engage it reliably, and you can prove that everyone is governed so that there can be no sort of cowboys in it breaking the process. And there needs to be evidence all around it, because if something does go wrong, or for that matter, you just want to reassure yourself that things are going well, you have to have concrete evidence that it is what it is, and things happen the way they happened, and you have proof. And that's really important. It's like, the server crashed, what happened? Okay, well, was there a change in the environment? Where did it occur? Who made the decision? Who approved? When did they approve? Can you prove how that system was built? And when I say system, I mean with lots of pieces, right? And it starts getting complex pretty fast. but it's a very critical function, an essential function. If you're on a plane or in a regulated, consuming something regulated, I think you'd want this. And so what tools do they have in their toolbox, right? These are conceptual tools. Obviously, they have templates for how to do things, whether it's in the form of documentation, templates to execute something like an SOP, for example. They have established processes of governance that they can prove. Like, we'll tell you how the governance works, and we will show you that it makes sense. They have authoritative repositories of evidence, meaning if I picked up the phone right now and I wanted to say, tell me where the official records for this server are, I should be able to know exactly where to find them absolutely reliably. And that's a lot harder than you might think. It's not on my thumb drive, it's not on a Google Drive, it's not on Dropbox, it's not on my laptop that just hard drive broke. Because when the regulatory agency comes in, or for that matter internally, and you want to get to the bottom of something really quick, you're gathering. And how do you know where to gather unless you have authoritative repositories? And how do you know what's in there is accurate? It's all extremely important. So this is what I call sort of the, you say, do you know French? Well, I have a tourist knowledge of it. I can get to a country and order something and I can understand. When some people enter our types of environment, these are some of the terms that are being used that frankly you don't necessarily learn when you're pursuing a technical degree. Some of these might be very familiar. I mean, what I would draw attention to is at this conference you hear a lot of people talking about security, for example. Security is usually in some form taught at a comp sci level, maybe. So you have some notion of what security is. You know some of the terms. You know what a firewall is. You know maybe what PII is. A lot of these terms, they sound familiar, but actually they're actually something you need to learn when you come into the space. Because when you are working with quality, you really want to understand what they're talking about. It almost turns gibberish when they start flying around with, is that qualified? Or is it validated? I keep getting confused. What does that mean? These are not terms to be taken lightly. They have very specific meanings. So just, it's there and it'll be in the slide deck. But, GXP is basically GX being a wildcard practices. So GMP is manufacturing, and there's other middle letters, right? So it refers to software construction, manufacturing, other things. And we use that as a conceptual term of a holistic set of guidelines and controls holistically that you can apply that represent comprehensive good practices around a given activity. Qualifications is about things. I can qualify this bottle of water that it is exactly what it is. Regulatory compliance, the minute you use the word regulatory, what regulatory very simply means is some third party is going to be looking at this. Usually a regulatory agency, a government, or someone else outside is going to come and look at it and expect it to be predictable in a certain way. And then validation, which is all about how things are used. And to put it in pictures, qualification. Here you just want to be able to show with industry best practices or guidelines that everything you have here is what you expect and it's working as you expect. So take, for example, a thermometer, right? In the context of thermometer, I've got mint in my mouth. I shouldn't have done that. You're recording temperatures. You assume you know what model the thermometer is and how you got it. And if something's wrong with the thermometer, the temperature reading's wrong, your data becomes flawed. Now, if you're just making a cake, okay, it's not really a big deal. But what happens if you're developing a chemical or measuring, the cabin of an aircraft or somehow involved in an engine of some sort? That's a very big impact. So there's a gradient of risk around how far you qualify something. Would you qualify the cake thermometer? I don't know. But you would definitely qualify the other things. Now here in the middle, we have some scaffolding, the SDLC, the System Design Lifecycle. In this context, it's sort of the mechanism by which you plan what you need to do and how to do it. You test, you demonstrate how you're going to test it. You're going to show how you record and generate evidence and proof, and you make sure you have comprehensive proof of things. And then you demonstrate control. So you don't plan for perfection, you plan for accuracy. So the thermometer is allowed to break, but you just need to understand how it got there, what happened when it broke, and then the evidence of, the results. So next we have validation. So on the right, a governing agency might look at this and go, okay, you're using these devices or using these things in a certain way in this framework. What sort of things can you ask about it? Is there a guide to how you use it? Is it set up properly? Is it calibrated? Do you have the evidence, the SOPs, the logs of it running? And by the way, do you have control over it? Can someone walk up to it and break it? Can someone walk up to it and uncalibrate it? Do you have control? And that's really important. So let's go back to that programmer, right, with the big thing on his head, or her head. When you think about DevOps and programming, and then you impose on it what quality needs as we go from portfolio, deciding what we're going to work on and the intention of it, we assess how it fits in, we start building plans of how we're going to build it, how we're going to test it, how we're going to prove it for quality, then we get around to coding. And as we code, we're recording things in evidence and automating and building tools to support it. It goes into quality and test phases to do that quality function as well as the software development type functions. And then finally it goes into production, and even then we're watching it from a quality perspective, run and execute. So what happens? What's left for coding? Not much. At least to the myopic programmer building the app. So how do you deal with this? So this is how we've deconstructed it. We start with some principles that seem to have been working so far. What you want to do is you want to create and support a core community and a framework and start building relationships and then the principles around where the community is going to align across the organizations. And very, very, very importantly, you adopt quality as a customer on every project. This is, headlines, neon sign. You have to literally treat them as the second customer to everything you're doing in this space. They're not the audit group. They're not the bar exam at the end of what you do. They literally sit at the table with you as you start, even when you think about doing it, because they have to do their job to ensure what you do is safe and risk, managed, and they will come to you over time for better ways with their intentions of how they're going to keep it running correctly, safe, predictably, as you try to innovate and invent along the same path. So you build a healthy, productive questioning of intent, because a lot of the quality organizations are coming in with decades of proven experience of how they did things, right? Even before the technology. They were working on pen and paper and who knows, before, there was even a PC. The industries go back, close to a century. So they have ways that have kept it safe so far, and you're looking at sort of the grandchildren of those processes when you walk into the space. So you have to be able to put yourself and build a relationship to the point where you have the ability to question the intent of everything they want to do, so that you're in the spirit of improving it and addressing it, and it's a two-way street. And through that, you might develop some common goals, maybe for different reasons, but you end up with common goals, and that's a revelation. Then finally, you start modeling improvement once you have this understanding, and you start using your DevOps good stuff. You take your DevOps toolkit out, and you start figuring out how to safely apply it with them. So let's talk about intent, because we talk about intent in this space a lot. When I was working on this presentation, my colleague was down in Florida, in Miami, when Irma hit. And he's in the background, he's remarking how the TV is telling everyone, go out, get bottled water, go get water. He was sitting tight. And he's like, I've been here, I'm staying home. I'm like, really? He goes, yeah. You need to listen to the intent of this. Well, what's really the intent? The real intent is you need to store water at your house. So he was busy going to his tap and filling up bottles and loading up carboys and all that, and he was fine. So he didn't need to go to the store, which, by the way, didn't have much water, and the traffic, was crazy, and ultimately the storm shifted and it got more chaotic. He was home with all the water he needed, and he followed the true intent of that message, but he actually, in his mind, questioned it. So the analogy here is, if a quality team is telling a development team, go get water, and they run and just go blindly get in their car and go get water, it may make sense for them to actually pause and try to understand the intent of what the quality team's asking them to do. To do this, they must basically look at the requirements of the quality. What do you want? What are you trying to achieve here? And understand the true need. By doing that, it opens up the dialogue on both sides for both of them to understand where they're coming from and how to apply the methods from both sides to solve these problems. It also, the same applies to when you're doing business and business requirements, but in quality, it's very much proven to be an important success factor. So, common interests. And this is also very revelation when you have a programmer team, because initially they come in here, you need to do these things, you need to fill out these forms, you need to check these boxes, you need to do it on this cadence, go get water. But then when you start educating both sides on how each other side work, the quality organization fundamentally isn't a technology organization, and the technology organization is typically not that incredibly deep and versed in quality in this sense. So you start boiling it down and go, okay, well, QA is very interested in they want quality per se to reduce risk. DevOps, they want to eliminate rework, right? They're all about getting to the right thing quick and being efficient. QA likes automation because it's the embodiment of consistency. If you don't have ad hoc processes and you have one that you just iterate on, that's very easy to demonstrate control, and it scales. DevOps does it effectively as a scaling and a reduction of technical debt. QA, they're all about evidence and documentation. DevOps, they want to be able to capture knowledge and move it forward so that they can efficiently operate and iterate. And then finally, QA really embraces simplicity, because once again, complexity equals risk in some cases. DevOps, it's fundamental. They like things as simple and as elegant as possible, basically for things as fundamental as performance. So when you get past this and you get to the common ground and you've got the QA organization and the technical DevOps staff all saying, wow, we have common ground, we have our different reasons for doing it, but in the end we both really want this, so let's co-invest. The DevOps side can start bringing agility to QA. Now, the first thing that matters in this space is there's an initial, I would say, learning that sometimes there's this notion of boiling the ocean. A technical person trying to please QA without this sort of precursor tends to boil the ocean. We're going to do absolutely everything, overcompensate, document everything, go 1,000%. That stretches out and creates incredible inefficiencies when it's not needed, and sort of goes counter to agility and Scrum and the ability to execute fast. So right sizing is really important, and what quality brings to the table is they have the expertise to correctly right size things safely. And you can sort of think about it, these are some categories of the way you categorize things in a quality setting. You have infrastructure like a router, like this box here, or like a road. It's put down once, generally speaking. It's put down safely. There's processes to get it started. There's processes to install it and probably deinstall it. There's guardrails, but generally speaking, it doesn't change. You might get a few minor enhancements, then you test it, but it's generally static. So once you've established it, you can treat it as a black box that you can check on every once in a while reliably. Microservices, other things that can be described as a black box that way in software lend themselves to that. Infrastructure is easier to qualify and validate, if you have things that are appropriately infrastructure. GXP-like systems, the more process-driven systems, a car, a self-driving car, an aircraft, a process that, does something at a nuclear reactor. Those things you absolutely want to have a much higher grain control over and a lot more artifacts, process checks, automation that confirms quality, and that's where you get that very long chain of Post-its on the wall, and rightly so. And then finally, there's the things that are obviously out of scope. If there was an app that told me when the taco truck was going to show up outside, so what? Yes, you might want to have good software practices with it, but realistically, you don't, it's okay. You can get the blessing from quality people that, okay, you don't need to worry about that, and we have your back. Or you can categorize this as infrastructure because it's appropriate. We can defend it, and we've documented why we made that decision, and that's actually how it works. And by the way, they're not interested in over categorizing something because it also represents work and complexity too, right? So understanding intent and combining it with right sizing makes a huge difference and increases the ability to move fast in these types of environments. So you get to this point, and I'll give you a few examples of where we're starting that have been sort of low-hanging fruit and big wins in this space as we go on our journey. And you can do it in small, incremental, agile ways, but then you can start measuring and seeing the impact. So for example, you're probably familiar with the robot framework. It's an automation tool that lets you orchestrate. And as we said, automation is the friend of both quality and DevOps. And so one of the first things we did in our environment was, in order to let people use these tools safely and feel confident that if they use it, they would not be breaking or doing something that quality would regard as unpredictable, we actually qualify the tooling. So if you use Robot or another qualified tool and you are using it for a process that could be audited, the Robot framework is ready to be audited. We've set it up in such a way and put all the stuff around it so that you don't have to worry about it. It's safe to be a participant in this system. So as an example, we did qualification testing, the thing that if you were to be qualified or down the road audited, what this represents is, actually that's a literal stack of paper. If you were audited in a paper-based process, you would literally go to the file cabinets and systems of record and the fire safe vaults and pull all that. Now obviously the business, oh my God, the QA people who have to go through it, that's a lot of manual work. And the teams that inspect, that's also a lot of work. And when it comes down to it, they're asking very basic questions like, how do I know that system was operating as intended? Here's the paper. And then they're going to sit with the paper very diligently and look at the SOPs, the work instructions, all the logs and pouring through them manually. Review the documents that describe how the system was being run and actually look for, it was the process that you ran a good process. And they go soup to nuts, line by line, and you can imagine how long it might take. Now, conversely, once you put some automation in, and this may seem like obvious, but in our this is hard. The first ones in are hard. The question turns to, You, technology, are auditing the system under automation. Show me the tooling. Well, we can show you that robot was qualified. It's a tool that we can prove was correctly set up, correctly installed, and we're running it in a traceable, reproducible way with output. Okay, well, now we're past that. Then they can get the confidence to go in and say, okay, show me the test using the tool for that period of time. Look at the automation documentation, and typically that's enough because you've established a trusted, regulated base or a qualified base, and you've educated them on how it works, and they've accepted and understand how it works. So now the question gets to the meat of their intent. They really just want to make sure the system works, right? So we've replaced an iterative test with wet signature cycles and with much more reliable automation. And we've taken, let's just say, human error even out of it too. And sneaker net, like for every piece of paper in here, odds are there's 2 signatures on every page that someone had to run around hallways to get approvals for when they did whatever was on that page. Fraught with all the things you might imagine. So here we go. So now when they show up to the audit, they don't bring that monster stack of paper and one page in that stack with that page on your right. What they can do actually is look at an automated test on the qualified system and bring in, through integration, all the data they want to see. And then, by the way, they can spot trends and all the goodness of visualization, and everything looks fine until they can be graphed. All that goodness flows right in with it, and suddenly that paper is looking more and more archaic. Now, another great example in terms of was to apply agile and automation to our release documentation process. Typically, when software is developed, they build up documentation over time as they code, and you can imagine a agile programmer in Scrum trying to write, or in a text editor, try to track and get signatures as they make changes and do things. Typically, when a big release comes, they spend a good portion of their time, literally days, building up a stack of documentation, just like they built up a whole stack of code to integrate and build. And what we were able to do is build into the DevOps process, where code is being submitted and automated and built, ways for the developer to build up documentation basically in small bursts, like micro bursts, and update their documentation as they update their code. And then when it's time to build a release, they basically hit a commit, a workflow, assembles the aggregation just like their code is being aggregated, and voila, they are compliant in an authoritative repository. They don't feel a lot of friction in the system, like, oh my God, I have to reserve a week to build up documentation. And quality loves this because it was predictable, reliable, they could count on them doing it, and they know where to find it, the system of record. And it was timely. They didn't do it retrospectively. It was actually being written while it was being coded. Wow, that's the bar. We just raised the bar really high. So what happened? What was the end result? Well, with DevOps, good thing is to measure how you did. We could actually measure and say, okay, when we look at the time in terms of schedules on a project, the amount of documentation time dropped significantly. And the developers were very happy, and quality was very happy, because we addressed the intentions of both. And that trust and demonstrating this bought us more credibility to do more. Another one is Jenkins. Going back to being able to reduce risk by reducing things we do to smaller tasks, another DevOps concept. So we basically were able to chunk up deployments to much smaller changes being deployed along with the automated artifacts that go along with it. And basically when we have to remediate, if it goes pop, you're dealing with 1 or 2 things that went through the pipe, as opposed to you threw 100 things into the pipe and it went pop, and now you have to figure out what happened. Once again, that fine-grained control is also a goal of quality. They like it. It dramatically, tangibly reduces risk. So adoption is a really great metric for effectiveness. We started measuring the use of these regulated or qualified services in our environment as we put them in. And as you can see, once people were educated on how they work, once we had a few significant tangible wins, adoption is going high, and the amount of time we're spending doing things also drops. Hence, we're moving faster, and quality seemed to have liked that. So, as I said, for summary, we have these core principles which I've talked to you about. And really, the messages here are about this. Cultivate your programmers and your technical staff as they enter these environments to learn to become, don't yield under the weight of your first impressions. Learn that you can become an orchestrator of all this and embrace what quality is all about, because they're on your side. In the end, you're going to build something great and important if you do it well and right and let quality do their job with you. And whether you're here and you're making the tools that help DevOps, raise the bar on the DevOps tide, that's awesome. Whether you are delivering solutions in this space using DevOps, I'm here to say your work is extremely important because it enables us to do this work. And we can drop times on producing important things. For example, in our case, therapies that help people get better. So actually Jenkins can help you potentially with a therapy, down the pipe. And if you're so inclined, I would ask you humbly, consider working in this space. It's hard, it's icky, there's a lot of old school versus new school, but the climate and the appetite and the motivation is all there, and you do hold a very valuable gift with what you're doing here with DevOps. And with that, I say thank you.
If you have any questions, please come forward to the microphone for the benefit of the recording. No questions?
Okay.
Oh, we got one. Quick one.
Hi.
Yeah, I probably will not end up in a heavily regulated environment, but I do find myself in an environment which could do with more quality. And I wonder, of all of the things that you've expressed here, where are the ones that you think low quality DevOps can learn the most? Like realistically, we've got this big lever of speed versus quality, and when you realize it's gone a little too far in the direction of speed, where can you get the most bang for buck in quality?
I think one of the biggest revelations, I hope it doesn't sound kitschy, is training and cultivating your people to work with whatever amounts to your test organization to understand intent. Because once you break down the intent which drives this mutual understanding, it isn't an over-the-fence thing. And then your ops people can see how your testers work, and that synergy tends to take off because life gets better for everybody and the quality goes way up. And it reinforces the appetite to do more. So you get away, part of your shiny work becomes actually improving quality. I hope that helps. Okay.
No further questions?
Thank you very much for your time, everyone.
Yeah, round of applause for our speaker. Thank you.